In how many ways can 5 boys and 5 girls be seated in a row if case 1, there is no restriction. In case of no restriction, 5 boys, 5 girls, in all 10 individuals, the number of arrangements possible is 10p10 or simply 10 factorial. Imagine if there are 10 positions, first position can be filled in 10 ways, second in 9 ways, third in 8 ways, and similarly the last one would be filled in only one way. That's how we get to 10 factorial. Second case, 2 particular boys always sit together, so they become one entity, and then there are 8 other entities. So in all we have 8 single entities and one pair, and therefore 9 entities. They can be arranged in 9 factorial ways, and then even these 2 boys can be arranged in 2 factorial ways. The answer is 9 factorial into 2 factorial. Third case, 3 particular girls sit together, so these 3 become one entity, and then there are 7 other entities, 2 girls and 5 boys. In all we have 8 entities, 1 here, and 7 of these. They can be arranged in 8 factorial ways, and then these 3 particular girls can be shuffled in 3 factorial ways. The answer is 8 factorial into 3 factorial. 2 particular girls never sit together. Finding out these cases directly would be very complex. The right way is to look at the total number of cases, and from these cases subtract the cases when 2 particular girls are together. So for example, these 2 particular girls want to not be together. Then from the total cases, 10 factorial, we are subtracting cases where these 2 girls are together. They would be together in 8 elements here plus 1 9 factorial, and these 2 can be shuffled in 2 factorial ways. So they are going to be together in these many ways. And if we subtract this number from the total, we are going to get the number of cases when they are not together. Look at this. All boys sit together, so boys become one entity, and all girls sit together, they become one entity. The 2 entities can be shuffled in 2 factorial ways, and now each entity can be shuffled in 5 factorial ways. That's the answer. This is very interesting. This means they are going to take alternate positions, either this or this. Girl, boy, girl, boy. In this arrangement, see, boys have 5 choices, so 5 factorial ways. Girls also have 5 choices, so 5 factorial ways. Or means plus sign always, and means multiplication, or means addition. So either this case or this case, we have OR case, and therefore we're going to add what we get here. In this case, see, girls can be arranged in 5 factorial ways, and for boys, again it is 5 factorial. So the answer is factorial 5 into factorial 5 into 2, not 2 factorial. Although the value is same, calling it 2 factorial would be conceptually incorrect. The answer is this. Look at this one now. No 2 girls sit together. Some students will think that answer to this question is same as answer to this question. That is not correct. In this case, the answer is going to be a bit more, because some cases in which no 2 girls are together but boys are together can be selected. See how to solve this particular question. This one has a very interesting and important concept. No 2 girls sit together. So in such cases, first arrange those elements on which there is no restriction. Boys have no restriction. So first let the boys sit. 5 boys can be arranged in 5 factorial ways. Now for girls, we have 6 places. If girls occupy any 5 out of these 6 places, they are not going to be together. They have 6 choices, and out of these 6 choices, they can take any 5 choices. So factorial 5 into 6p5. See, this answer is a bit bigger. In this case, we had got factorial 5 into factorial 5 into 2. This answer is bigger because certain cases, such as a case where this is the arrangement, see, no 2 girls are together, so the condition is being met, but see, these 2 boys are together. So these are various extra cases that you get, and therefore a bigger answer. Please try the next one yourself. Another girl is added, and no 2 boys sit together. So this time the restriction is on boys. So first have the girls seated. There are 6 girls. 6 girls can be arranged in 6 factorial ways. And for boys, there are 7 places now. 1 extra because of the edges. Out of these 7 places, 5 have to be occupied by boys. Order matters, of course. So into 7p5. That would be the answer. A very important slide this. If you can solve all these questions, you have a fine idea of the basics of permutations. This was the concept, guys. GMAT shorts are deliberately kept brief. For an elaborate explanation, please refer the stage 1 videos. Thanks for watching.